Hello students, welcome to your Chapter 8 review video. In this video we're just going to briefly go back over all the sections of Chapter 8 that we've done so far, sections 1 through 4, and then we will take a short quiz on these 4 sections. And we will start way back in section 8.1 when we first talked about the Pythagorean Theorem, a squared plus b squared equals c squared, as a reminder of that formula and that what it allows us to do. And then we extended it a little bit with something called the Pythagorean Inequalities. The application of the Pythagorean Theorem that I hope we're all the most comfortable with would be something like this, where you're given a triangle, a right triangle specifically, and you're given 2 of the side lengths and asked to find the length of the third side. So what we can do is we can set up the a squared plus b squared equals c squared just with our unknowns, and we can solve for the unknown value. That's not supposed to say plus, it's supposed to say equals. Equals 15 squared. In this case, x squared is equal to 225 minus 144, which is 81. Square root both sides, and x is equal to 9. Now remember, when you do not get a perfect square number here that we can't square root, you can, for a bonus point, simplify the square root by splitting it up, or you can just use a calculator, get a decimal approximation, and that's also perfectly fine. Okay. The other thing that we did in this section was we found or determined what type of triangle do 3 side lengths make. Okay, so we were given 3 side lengths of a triangle and asked to decide, is that a right triangle or an acute triangle or an obtuse triangle? And to do that, we used the Pythagorean theorem, but we sort of extended it, as I said, into the Pythagorean inequalities. So the inequalities essentially ask us to compare the c squared value to the a squared plus b squared. If they're equal, it's a right triangle, right? Then they're what we call a Pythagorean triple. If the c squared is bigger, larger than a squared plus b squared, then it's an obtuse triangle because that angle is bigger than 90 degrees. If the c squared is smaller than a squared plus b squared, then it is an acute triangle because that angle is less than 90 degrees. So in this particular case, we would be taking the c squared value, which remember is always the biggest one, and that in this case is 25. And we would compare that to 12 squared plus 15 squared. Okay, 25 squared is 625, and then 12 squared is 144. 15 squared is 225. So we would add those together and we get 369. So is c squared, this 625, bigger or smaller or equal to the a squared plus b squared? Well, in this case, it's bigger, and so we would say obtuse triangle. Right? But if it was smaller, we'd say acute. If it was equal, we would say a right triangle. So those 2 things, or those 2 types of problems are what you may see on your quiz. So if they're confusing, you need a little extra practice, make sure you go back and do that. Section 2, lesson 8.2 was about special right triangles. So we had 45, 45, 90 triangles, and we also had 30, 60, 90 triangles. And we had formulas for each of these triangles and their side lengths, okay? Specifically how the hypotenuse was related to the 2 legs. In a 45, 45, 90 triangle, it's important to remember that both of our legs are congruent to each other, so we really just have one formula that compares the hypotenuse to the legs, and that formula says that the hypotenuse is equal to the leg times the square root of 2. Okay, the leg times the square root of 2 is the hypotenuse length. So if we know that the leg is 3, then we know that the hypotenuse is 3 times radical 2. And remember, these are the ones where you do have to write your answer in a simplified radical form. The good news is simplified radical form generally just means with a radical 2 on it, or in the other example, a radical 3. So this is our rule for 45, 45, 90 triangles. For 30, 60, 90 triangles, we have two different rules because we have a shorter leg and we have a longer leg. Okay, we have a short leg and we have a long leg. So the short leg is what everything is based on for a 30, 60, 90 triangle. So remember that the hypotenuse is equal to the shorter leg times 2. It's twice as much as the short leg. So if you know that this short leg over here is, for example, 8, then the hypotenuse must be 16. And then the longer leg, the longer of the two legs, is equal to the shorter of the two legs times radical 3. So in this case, it would be 8 times radical 3, right? So remember, we had a 1, 2, radical 3. That's how we sort of remembered that rule. Those should be in your notes somewhere. And that's really what you're going to be asked to do. You're going to be asked to look at these triangles and determine what are the side lengths for these special right triangles. Okay, so make sure your rules are written down. If you have questions about them, let me know. Lesson 8.3 was where things got really interesting. Okay, things got interesting. Things got trigonometric. We started talking about trigonometry. We started talking about sine. Started talking about cosine. Started talking about tangent. Okay, and remember, the sine of some angle, of whatever angle, is always equal to the opposite over the hypotenuse in terms of the triangle's side lengths, right? We make a fraction here. The cosine is the fraction of the adjacent over the hypotenuse. The tangent is equal to the opposite over the adjacent. And we sort of simplified these three ideas to SOHCAHTOA, right? We talked about getting in a hot tub. We talked about some old hippie and another hippie tripping on acid and all these different ways to remember this, okay? Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, now what that allowed us to do was we were then able to find missing pieces of triangles. In particular, we were able to find a missing side lengths. If, let's say, we knew this angle here was 35 degrees, and then we knew this side was 7, and we wanted to find the hypotenuse, we would recognize that the 7 here is the adjacent side. The x is the hypotenuse. Adjacent and hypotenuse is cosine, so we would say cosine 35. Cosine of 35 is equal to 7 over x. We would get cosine of 35 as a decimal, put it over 1, and then do our fish method or cross multiplication. Okay, and solve for x that way. It also allowed us to find missing angles, but remember, for that we had to use an inverse. So for example, if angle B up here was what I wanted to find, I'll call that x. And if I knew the hypotenuse, let's say length was 10, I could set up for x, the 7 is now the opposite side, the 10 is the hypotenuse, and so I would set up the sine of x is equal to 7 over 10. And then remember, I'm allowed to flip the x and the fraction by changing it to sine inverse, which we do have on our calculator as well. 7 over 10 is equal to x, and then we just use our calculator, making sure the mode says degree, DEG, and you figure out the angle x, okay? So if you're unsure about how to use sine, cosine, tangent to either find missing side lengths or find missing angles with the inverse, do please let me know, okay? And then our last section was about angles of elevation and depression. We basically did word problems here. We talked about angles of elevation being looking up at something, angles of depression being looking down at something. So if, for example, we have the Washington Monument here and some spectator who is 5 feet tall is looking at the Washington Monument, if they are, let's say, standing 400 feet away from the Washington Monument, and the angle of elevation that they look up at is, let's say, 52 degrees. How tall is the Washington Monument, right? That would be the question. How tall is the Washington Monument? And what we could do is we could then figure out, okay, we can figure out this length up here, right? We can figure out this pretty easily. And then we just have to add the 5 feet on the bottom, right? We just have to add the 5 feet on the bottom. And that will tell us the total height. So we're looking for this side, which is the opposite side from the 52-degree angle. We know this side, which is the adjacent side, right? The straight line of sight from the person's eye to the top of the tower is the hypotenuse. We don't know that. We know opposite, or we want opposite, and we know adjacent. Opposite and adjacent, so we're setting up tangent here. Tangent of 52 degrees is equal to x over 400. Again, we can get the tangent of 52 as a decimal, put it over 1, and then we can just do our fish method, cross multiplication to find x. And then once we find x, we add the 5, and we've got our answer. So if you have questions about angles of elevation, depression, or how we set up triangles to then use sine, cosine, and tangent to solve these types of problems, do please let me know. That's really all we did in Chapter 8, Pythagorean Theorem, special right triangles, trigonometry, and then these word problem applications. So if any of that is confusing, or you're not sure, or you're not ready for your quiz, reach out to me, let me know, and I'd be happy to help. Otherwise, that's all I have for you right now, and we'll talk to you soon.